Hello and welcome to Math with Mrs. Havrilla. This is Mrs. Havrilla and today we are going to be working on Unit 4, Lesson 11. In this lesson, we are continuing with division and we're specifically using multiplication to help us find the answers to these division equations or these quotients. Starting with number 1, we have Cassandra, and it says that Cassandra began to find the quotient of 408 divided by 12 using the strategy below. So she had 408, she's dividing it by 12. She started with 240 divided by 12, and that gave her 20. Then she did 120 divided by 12, and that gave her 10. And then there's a mystery number. This is the one that we have to figure out, that she divided by 12. And when she did all of that, she ended up with a final answer, 408 divided by 12, of 34. When filling in these blanks, I need to think about what she's doing. I can see that every single equation here, she's dividing it by 12, which is good because that's our divisor. So now I'm wondering, well, where is she getting these numbers from? Well, I can see that when I look at these, I have 240, I have 120, and I have a blank. And I also know that it needs to be 408. So in my mind, it looks to me as if she's decomposing. Now, why would she have decomposed it this way? It looks like she's looking at her multiples of 12. So she knew that 12 times 2 gives her 24. And she could add a 0 onto that to make it 240. So she's counting by 12s in her head to do multiplication and then subsequently division. That's going to be easy for her to do. So in order to figure out what's missing here, there's a couple different things that I could do. I know that the final sum, when she adds these together, is going to be 34. So that means I have 20, I have 10 for 30. That means this has to be 4. But I can go ahead and check to see if that's right by now looking at this side. These numbers added together are going to have to equal 408. Well, so far I have 300 and I have 60, 360. That means that I need another 48 in order to get to 408. 48. Let me check. 48 divided by 12 equals 4. I know that I can check that by doing 12 times 4 to get 48. So now all of my numbers here add up to 34, and all of my numbers here add up to 48. So really, she was using a decomposing method to divide, which allowed her to use numbers that are easy with her 12s times tables. For B, I'm going to backtrack. Let me go ahead and fill in 48 and 4 on my lines. And for B, it wants us to explain or show a way that we can prove that this quotient is correct, this final quotient of 34. Well, anytime I'm doing division, I can check my work with multiplication. So what I would do is I'd take that divisor of 12, I would multiply it with my quotient here of 34, and as long as the product that I get is 408, then I know that I'm correct. Let me go ahead and multiply. I know that 4 times 2 is 8, and 4 times 1 is 4. Now I have to multiply my 30, so I'll drop down and put a 0. 3 times 2 is 6, and 3 times 1 is 3. Now I'm going to go ahead and add those together. I get 8, 10, and 4, which means I ended up with 408. So in my section for B, where I'm explaining or proving that 34 is correct, I'm going to have to show my work by doing the multiplication to check. So that is going to be my answer for B, is that multiplication. All right, I'm going to turn to the back. On the back, I have a set of expressions, and it says to look at these expressions and to circle a set that when added together will be used to find the quotient of 805 divided by 35. And you can see I have quite a few listed here. Well, the very first thing that I know that I can do is I can eliminate any set or any expression that is not dividing by 35, because I'm not decomposing that divisor. I'm only decomposing the dividend here. So I'm going to go ahead and cross out 350 divided by 10 and 700 divided by 10, because both of those are not using our divisor of 35. And now I'm going to go ahead and I'm going to look to see if there's a combination of equations that I can use that when added together will give me 805. Well, I have 350 here, and I know that to get from 350 to 800, I'd have to have another 450. Well, I have a 700 here, and that's too much. And I know that 70 and 35 together will not equal 450. So I'm going to cross that one out. Now I have 70, 35, and 700. And when I add those three numbers together, let me go ahead and do that. 700 plus 70 plus 35. Hopefully that's going to give me my quotient of 805. And it does, which means the three numbers that we're going to be using to decompose are 35 divided by 35, 700 divided by 35, and 70 divided by 35. All right, now that I've circled those, what I'm going to do is I'm just going to set up each of these to help me divide. So putting them all here in a line. And it looks to me as if this is actually going to be hopefully a little simple for me, because it looks like my 35 is going to be going into all of these numbers. Starting with the first one, I know that 35 can go into 70 2 times, because 35 times 2 is 70. And then I have this extra 0 on the end. So I'll put a 0 onto my 2, and that means that 700 divided by 35 is 2. For my next one, I have 70 divided by 35, which is 2. 35 times 2 is 70. And then last, I have 35 divided by 35, which is going to give me 1. All I need to do now is add together these numbers, the 20, the 2, and the 1, and I should get a final quotient of 23. Moving on to number 3. Number 3 says, Miss Honeywell sold 91 cupcakes at a bake sale. The cupcakes were sold in boxes of a baker's dozen, which is 13. It says, how many boxes of cupcakes did she sell? Well, what we're going to have to do is we're going to have to take the number of cupcakes total that she sold, and we're going to have to split it up into these baker's dozen, which we know is 13 based on this problem. So we're going to do 91 divided by 13. Let me set that up. All right. To do 91 divided by 13, I'm going to go ahead and set up as my partial quotient strategy here. So when I'm using partial quotient strategy, I'm finding numbers that are going to be simpler for me to solve or to multiply in order to solve this problem. So looking at this, I know that I can do 13 times 3. That to me is an easy number to multiply because I don't have to do any regrouping. Why? Well, because 10 times 3 is 30, 3 times 3 is 9, so it's just 39. I don't have to regroup at all. So now that I got 39, I'm going to subtract 39 from my 91. Once I do that, I'm going to have to regroup here, making this an 8, making this an 11. Once I do that, I get 52, which means I can fit another 39 in there. I'll do 13 times 3 again. I have to do a little bit of regrouping there, but not anything too terrible. I get 3 and 1, 13. That means I only have one more group of 13 here, so 13 times 1 gives me 13, and I'll go ahead and subtract to 0. Now I can go ahead and look for my answer by seeing how many groups of 13 I was able to get. First I started with 3, then 3 more, then 1 more, giving me a total of 7 sets of 13. And what are those sets of 13? Well, they are boxes of cupcakes. So she sold 7 boxes of cupcakes. The very last question says, how much money did she make at the bake sale if she sold each box for $15? So she sold 7 boxes. She sold all 7 of them for $15 a piece. So I'm going to take the $15. I'm going to multiply by 7 boxes. And this is dollars per box, if I want to be specific. And I'm just going to multiply. 7 times 5 is 35. Place the 5, carry the 3. 7 times 1 is 7, plus 3 is 10. That means that she made $105 selling her 7 boxes of cupcakes. So $105 was made. All right, that's all we have for today. So be sure to check in next time for help with your nightly homework.